Hello and welcome. Today on the 59th lecture, let us discuss about the technological readiness as far as India's climate action is concerned. So this is the fourth lecture of 12th week and we will travel through these concepts. The first is what is the definition as far as the technological readiness is concerned, and its relevance to climate transition. The TRL stages classification we will discuss. We will also discuss the TRL, the technological readiness level, and the net zero climate targets. Further, we will go towards understanding the TRL mapping of carbon dioxide removal methods and some specific analysis. Trade-offs also we will try to understand in terms of climate transition, and then we will see what are the integrated framework and policy pathways as far as the technology readiness level is concerned. So, what do we understand by technology readiness level? This particular means 9 levels of technological readiness, or you say technology readiness level, TRL. This talks about the framework which has been proposed by Government of India. So on behalf of Government of India, the CIA, Confederation of Federal Industry, has generated this document very recently, and it is also jointly taken care by the Principal Scientific Advisor to Government of India. And look at this, the technological readiness level 1, 2, 3, 4, 5 on the left hand side and 6, 7, 8, 9 on the right hand side. So first we are talking about the technology development stage. If we move from 1 to 9, this talks about the basic technology research, research to prove feasibility, research to this is for second and third level of technological readiness. Moving to 4th, 5th and 6th, we have technology demonstration phase, and then in the 7th and 8th, it is system commissioning phase, and in the 9th level, it is kind of system operational or operations. So definitions as far as the first one, level 1 is concerned, it is basic principle observed and reported. As far as the second is concerned, it is technology concept formulated. Third talks about experimental proof of the concept. Fourth talks about the component and or the system validation in lab. The fifth one talks about laboratory scale similar system validation in a relevant environment. The sixth one talks about engineering or pilot scale prototype demonstrated in relevant environment. Seventh talks of full scale system prototype demonstration in operational environment. And the eighth one talks about the system completion or the system complete and qualified through test and demonstration. So then the ninth one is the highest level of technological readiness that talks about actual system proven in operational environment over full range of expected conditions. So on the right hand side, against each of these technological readiness level, their description have been mentioned. So why the technological readiness matters in climate transition? It determines feasibility of decarbonized pathways, in such as, let's say, it influences investment decisions, policy timelines and risk assessment. So in a sense, if there is low technological readiness level, then there is high uncertainty and cost factor also goes very high. Vice versa, in terms of high technological readiness level, it is a scalable and offers a deployable solution. With respect to all these 9 stages, the first 3 are broadly put under a research framework. The second are pulled under the development stage, and the third are put under the final stage of deployment. So research, mid-stage deployment and the final stage deployment. So on the left hand side, if we try to plot the resources versus technological readiness level, we will the red curve talks about the if you move from 1 to 9 in terms of technological readiness level, we can see from basic research to prototype and system development in order of increasing order of development and confidence. And then at the initial, or you say the very basic and applied research, always the government labs and academia are involved. Then when it goes beyond 2, 3, 4 stage, then small business SMEs, small scale business units, or some private sector, they also start taking interest. So beyond 5, that means 6, 7, 8, 9, we tap, and lot of interest comes as far as the private sector and large business is concerned. So that is the kind of balance between resources and technology readiness level, and involvement of various players across different sectors, starting from academia, government, small business, private sectors, and also the large business units. Coming to the technological readiness and climate targets in terms of net zero. So the key insights as far as IPCC and IEA are concerned, we need to achieve net zero. So if net zero to be achieved by 2050, so it depends on high technological readiness. That means whatever solutions or technological solution are at the readiness level of 6 to 8, they should be rapidly deployed now at the immediately. And the technologies which fall under the readiness of 3 to 5 range, they should be made commercial as early as possible by end of next decade, 2040. So if we need to achieve, the world needs to achieve in general the net zero by 2050, this should be the target. The high or mature technologies with respect to TRL level 6 to 8 should be deployed now, with 3 to 5 should be made commercial by end of next decade. So the critical reality is it leads to 50% reduction of emission that would rely on technologies not yet commercially available. So if we do it, then 50% reliability will be there, or vice versa otherwise. So the core dilemma, climate urgency is immediate. So a lot of technological development and their TRL level reliance, for that we cannot wait. So that means we need to act fast. And technology success is uncertain. We cannot assume that it is 100% reliant. So that is why we need to come from 1 to level 9. So at 9 we say that it is at a mature level, and the reliance or uncertainty is high, and reliance level is also uncertainty level is low, and that is how reliance level is high. So the policy challenge, it sets ambitious targets while managing the technology uncertainty and risk implication. That means we need to accelerate innovation and diversify the technology portfolio. Look at a depiction as far as the technological readiness level of clean energy technology is concerned. So but at the level of 4, we have the small prototypes ready. Between the level of 4 to 5, we have some peroxide solar cells are ready. 5 to 6, large prototype, next generation of geothermal energy ready. And 7 to 8, the demonstration phase, we need advanced biofuel, sodium ion batteries. And 9 to 10, that means we have more than 9, we have market uptake, and technology is really mature. So that is how the technological readiness of clean technologies are understood or mapped. Now let's move on to the TRL or technological readiness level and the CO2 removal methods. So coming from 1 to 9, so you see the cyan color have ocean based approaches. The dark green color are following the nature-based solutions, and the light green are the BISAG, and the dark blue are mineralization-based approaches. And coming to the magenta, it is oxide or some oxide looping. These are solid substance, and all these things, they fall under DSCCS. So let's move on to see what are the various levels of TRLs as far as carbon dioxide removal methods are concerned. So artificial downwelling, TRL level 1 and 2. Ocean alkalinity enhancement, ocean acidification, TRL level up to 5. Algal cultivation, direct ocean capture are up to level 6 and 7. Even if artificial upwelling are between 4 to 5. Now move on the biochar. This is at a very high level of reliance. So it touches reliance level or the what you say TRL level 9. As far as reforestation, afforestation and soil carbon sequestration is concerned, they are the nature-based approaches, and they are very what you say confident and well-reliant technologies. So they are at TRL level 8 and 9. Similarly, the carbonation and minerals technologies are between 6 to 9 or 6 to 8 TRL level. So this is how we categorize the technology readiness level as far as the carbon dioxide, various carbon dioxide removal methods are concerned. So look at the technology specific analysis from TRL prospects. So just two examples. On the lower left, you can see a solar photovoltaic cell, and this has already reached the TRL level 9. The technology is ready, well in market. So it's a mature, commercially dominant technology. Cost is very less, more than 90%. So what happens during 2010 to 2023, the cost has come down by 90%. So when the technology is matured really, and the cost also goes very less because people rely and more sell in terms of the quantity, and that brings the cost factor down. Cheapest electricity sources globally as far as this solar PV photovoltaic cell and wind energy is concerned. But the challenge is grid integration and storage facility. So as we have discussed in some of the previous classes, lectures, we have discussed this in that the storage and grid integration facility are also being taken up at a very high, at a very progressive scale, so that this also reaches the TRL level 9. Or matures or contributes to attaining the TRL level 9. Now look at the second one, that's the green hydrogen, which is between, the technological readiness is between 6 and 7. So this is the green hydrogen are key for industry, shipping industry, particularly shipping and aviation decarbonization. The current cost is $4 to $8 per kg, vis-a-vis 1 to 2 kg per fossil fuel based energy. So if it is a coal based, it is 1 to 2 kg, but if it is a green hydrogen based, it is 4 to 8. So that is why it is in technology readiness level 7. So we need to make it more and more mature and reliable, so that cost factor will come down below the fossil fuel. So the need is gigawatt scale electrolyzer deployment, but the challenge is scaling and the cost reduction. So then only it will move up on the order in terms of technological readiness level. Integrating the technological readiness level, trade-offs and just transition. A systems approach to sustainable transformation. So sustainable transformation is not achieved by choosing between technology equity and efficiency, but by aligning with whatever possible aligning what is possible, particularly in terms of TRL level, what is acceptable in terms of the trade-off. Trade-off, as we discussed, trade-off in terms of just transition, in terms of what you say, environment, economic, and social feasibility point of view, and what is fair in terms of the just transition. So it is a very important and a very critical point. Look at this. So we have a technology at different different technology readiness level, and there has to be also a trade-off between the just transition and the TRL level, or the technology at various TRL level integration. So this needs a system approach to sustainable transformation. These three frameworks solve different pieces of the same problem. That means just transition, who benefits because of the new technology coming in, and who loses because the old technology phased out. The trade-offs, what we gain versus what we sacrifice. But in terms of the technological readiness level, what is actually feasible right now is more important. So the integrated framework is assess the technology readiness level. So ask the question, is the technology deployable now, or it is at experimental stage? So that is how the technological readiness level is numbered between 1 to 9. The step 2, identify the trade-offs. So trade-offs, as I mentioned, in terms of the economic cost, the jobs, environmental in terms of land, biodiversity and other things, social in terms of equity and displacement. So these are the questions we need to ask as far as we are evaluating the trade-offs between the technological readiness integration and the just transition. The step 3 is apply the just transition lens. So that means who loses income, who gains opportunity, what compensation mechanisms are needed. So this in terms of the the diagram, what is the flow diagram, what is mentioned there, integration, that means just transition into trade-offs into TRL level. So who benefits, who decides, who are protected. So equity lens on all decisions and social dialogue. As far as the trade-offs is considered, the speed versus fairness, growth versus limit, local versus global scale, multi-criteria analysis and scenario planning, these all need to be considered under the framework of trade-offs. And then coming to technological readiness level, what is ready, what is needed. So the R&D investment priorities and innovation policies. So together all, when integrated, they provide the transformation pathway. So that means deploy mature technologies at speed, because you have a low cost and safe, and also it is reliable. Protect affected workers, because you need to maintain a balance, a trade-off. Protect the affected workers who are going to lose the job because of just transition. Invest public capital to cross the valley of death. Use trade-off analysis to resolve conflict transparency. So this is how we use trade-off to analyze, to resolve the conflict and bring out transparency in the system. So it is really important to maintain a difficult balance, or you say the trade-off between the technological readiness level integration and just transition. Moving on, as far as the policy pathway is concerned, so policy pathways trade off between TRL and just transition. So pathway 1, low TRL plus high social risk. Pathway 2, high TRL plus moderate trade-offs. Pathway 3, high TRL plus high social disruption. So example, hydrogen steel, CCS example is hydrogen steel, or CCS challenges, that mean carbon capture, utilization and storage, or sometimes you say carbon capture storage challenges. So you see, as far as these two technology are concerned, there is high uncertainty, high capital cost, and delayed job transition. So that means they are at a low TRL level. So that is why high social risk. So as far as the policy strategy is concerned, invest in R&D sector plus pilot projects, avoid premature large-scale mandates, provide income support, reskilling programs. So you give lot of support as far as various other income sources are concerned, and also skill them, train them, and train them as far as a new technology, as far as a new situation, or as far as a new job is concerned. Now moving to pathway 2, high technology reliable readiness level, moderate trade-off. Okay, so high technology and moderate trade-off. Example, solar and wind energy. So, but the challenge with respect to solar and wind energy are land use conflicts, local resistance, grid integration issues, and as far as policy strategy is concerned, rapid scale with safeguards, community participation models, land compensation mechanisms. When we move to the pathway 3, there we are saying it is high social disruption but high technological readiness. Example, EV transition. Challenge is job losses in traditional sector, supply chain restructuring. So, policy strategy, workforce reskilling, and industrial transition policies, gradual phase out, not abrupt or not to complete ban. So it has to be gradual, so that new jobs will come up, supply chain will be modified and gradually taken over. The workforce will be reskilled or newly skilled with respect to new setup or just transition, so that the gradual phase out will not trouble or will not disrupt the society or societal chain. Now moving on to India's national technology readiness and the assessment framework. So friends, just very recently, as recent as last month or a couple of weeks back, we got the National Technology Readiness Assessment Framework. It is a comprehensive guide for assessing scientific and technical project proposals. As you know, it is mentioned that developed jointly by the CII, Confederation of Indian Industries, and on behalf of the Principal Scientific Advisor to the Government of India. So the front page looks like this. It is a comprehensive guide and also a kind of assessment framework. Now look at example as far as 4 different sectors are concerned with respect to their technological readiness and the challenges. So first, power, solar, wind and hydropower, high technological readiness, but the challenges is non-fossil sources supplied the majority of new generation in 2024 to 25 for the first time. Coming to the transport, electric two-wheelers and three-wheelers in terms of mature are over 86% of total EV sales in these segments 2024 to 25. Transport, hydrogen power trains, they are in trial. So trials began early in 2025 for more narrow gauge routes. Industry, particularly the CCUS, the carbon capture, utilization and storage is emerging. 5 test beds launched in the cement sector by late 2025. So coming to the state level climate readiness index. So let us rank some of our states as far as their climate readiness index is concerned. So Gujarat leads in terms of technological readiness, accounting for 48% of India's solar manufacturing and 35% of solar park capacity. So it is the leader, followed by Rajasthan, which ranks high due to its leading position in installed solar capacity over 21,000 megawatts. Then coming is Andhra Pradesh. It tops the list for systemic readiness, governance and policy framework. As far as Chhattisgarh is concerned, it leads in financial readiness with a 93% rise in central implementation fund. So this is the way the various states have been ranked as far as their climate readiness index is concerned. So to prepare the slides, we have taken help of these literatures, the IPCC Assessment Report 6, Working Group 3, the IEA report in terms of net zero by 2050, a roadmap for the global energy sector. Also taken help of the TRL lab, the Technology Readiness publication by NASA, and also guidelines for just transition given by ILO, International Labour Organization, and the 2021 document published by the Energy Resources Institute in Delhi, India. So it is on just transition in India. And also the very latest one published by National Technology, published on National Technology Readiness Assessment Framework, NTRF, developed by CII, Confederation of Indian Industry, at the behest of Office of Principal Scientific Advisor to the Government of India. So to conclude, the TRL, or you say the technology readiness level, determines what is possible but not what is socially acceptable. So TRL determines what is possible, but we also need to know whether it is socially acceptable or not. So that is where a trade-off is required. The trade-offs are unavoidable but must be managed very transparently, because you need to maintain a difficult balance between the technological readiness or integration of the technologies and also take care of the social aspect, the environmental aspect, and the economical aspect. And also this has to be rooted through policy framework. So that is where the trade-offs we say are unavoidable. Just transition ensures social legitimacy and long-term sustainability. So if we move in terms of this, if we take care of the trade-offs in terms of just transition, then it will ensure social legitimacy and also sustainability in longer term or long run. The integrated three-step framework, particularly, first is assess the technological or technology readiness level. Second, identify the trade-offs. Third, apply just transition lens. All these three together provide a practical decision architecture for the policymakers. The fifth point is sustainable transformation is achieved not by choosing between technology, equity, and efficiency, but by rigorously aligning what is possible, what is acceptable, and what is fair, and making that alignment the explicit accountable work of governance at every level. So friends, to summarize this lecture or the discussion that we had today, in this are three. One is various technological readiness levels are available as far as energy sector is concerned or any other technology is concerned. We need to achieve the maturity level, that is technology level 9. Whatever technologies are at level 9 needs to be implemented now without further delay. The technological readiness level with 5 or beyond, or you say 6 to 8, should be made market worthy, that means reliable and cheap, by end of next decade 2040, so that it will go for a wider usage. Finally, a trade-off has to be maintained between integrating different technologies as far as their various technological readiness level is concerned, vis-a-vis the social acceptability in terms of environmental, in terms of social, and in terms of the economical cost are concerned. So this is what we discussed in terms of the technological readiness levels and the trade-offs between or with the social acceptance. Thank you very much.